Hey all, welcome to Tutelings. In this tutorial, we will implement a Python-based FastAPI application that has asynchronous REST endpoints with create, read, update, and delete operations, and that uses SQL Alchemy and databases package and has Postgres as a database. So without further ado, let's get started. To start our development process, let us first begin a workspace to start development. So I'll be creating a new directory and open Visual Studio Code. Here I am on Visual Studio Code and open my workspace. So I'll start off by creating a Python virtual environment by typing Python n, and env will be the name of the virtual environment. So wait till the virtual environment gets created and the Python will ensure the necessary executables and binaries will be added to our virtual environment. Okay, and activate the virtual environment by typing env scripts and activate. Now we see the virtual environment got successfully activated. So we will install all the required dependencies by using pip, but before that we'll upgrade the pip. So wait for the pip installer to be upgraded. Okay, we have pip successfully upgraded. Now let's install the FastAPI package by typing command pip install FastAPI, and then we will install other dependencies such as Uvicorn. Now let's install Uvicorn. Okay, let's wait for the installer to complete the installation of Uvicorn. Now we will install databases package that provides asynchronous capabilities for any database. So we'll install databases for Postgres because that's what our database is going to be. Uh, the actual command is PostgreSQL, and yeah, okay, we have a databases package for PostgreSQL successfully installed, and optionally we will install Gunicorn. This will help us freeze the requirements. Uh, this version of Gunicorn will be compatible with all other uh, modules within our library. So now we will freeze all the installed requirements along with its versions by typing pip freeze required files.txt. This could be any file, but I just give a standard naming convention. So you will see the requirements.txt file that got created with all other modules that are dependent in this project along with the versions. Okay, so now we will create a file main.py where we start developing our application that has asynchronous REST endpoints, and create, read, update, and delete REST endpoints that talk to Postgres database asynchronously. Now we will start our development by importing the necessary modules URL lib. So first of all, we will build a database URL, which is often termed as connection string for us to connect to Postgres database. So, so first we will have the host server, and then we will have the server port, which is predominantly 5432 for PostgreSQL database, and then we will have a database name. For the demonstration purpose, I have already created a database named FastAPI in my instance of PostgreSQL server. So next we will have the database username, and I will have database password, and this SSL mode is a variable which is required if your instance of PostgreSQL server enforces SSL requests. So the possible values for this is preferred and required. And finally, we format the database URL from PostgreSQL, and then followed by username, password, host server, database server port, database name, and SSL mode. So the idea of having these distinguished values read from environment variable is that in production environments, you will have these environment variables stored as secrets. So if those are now not available, I am reading the default values from the second argument of the get method. Okay. Proceeding further, I'll go on and define the SQL Alchemy model by importing SQL Alchemy, and metadata will be SQL Alchemy's instance of metadata. And here in this tutorial, what I'm trying to do is to have a to-do notes that will have two entities, two properties actually. So one is the thing or the text that describes what to do, and the another property describes the status of completion. So the corresponding SQL Alchemy schema for that will be like this, and we will create an engine. So if at all you do not have a PostgreSQL server installed or access to any of the cloud hosted or remote PostgreSQL, you can go on with the tutorial by accessing the local SQLite database by uncommenting this line and commenting this database URL, and comment this database URL line and uncomment this. So as I have the access to the hosted instance of PostgreSQL database server, and I'll go on with the actual communication with the database. So once the engine is created, so we would like to have the notes table to be created in the database. If at all the notes database table does not exist by this piece of line. So the next thing is we are going to import Pydantic models, and we will define two models that will be used as a part of exchange the information between the consumer and to the API. So let's go on and define those. So here the noting is used to accept the new node or update a node that is being created or modified, and the node is the response uh, model that we will display it in the response of the API. And finally, we'll go on with importing FastAPI related modules and create the instance of the FastAPI and add cards. Cross-origin resource sharing capabilities are essential for any REST API to control the consumers of our API. So if your API is being consumed by some example site like example.com, so it has to be added here. And remember that www.example.com is different from sample.com. So if at all you are having a site that accesses this REST endpoint from these two clients, then it is essential to have these two specified as different domains. And if at all you are performing access to this API from localhost, so, such as Vue.js or React.js, mention that local server here. So I'll remove that and allow all the origins to access my API. So I'll go on with the start, but this is not the recommended practice, and you should avoid and have a predefined set of origins. And going forward, I'll import the module databases that will provide asynchronous capabilities to communicate with PostgreSQL database. And now I'll create the instance of databases with the database URL that I got, and I'll connect to this database whenever the Fast API starts up by using the event on event startup. Startup is the event that gets invoked whenever you start a fresh instance of Fast API, and I would like to disconnect to the database on the event of shutdown. So I could do it by having this event invoked and database gets disconnected asynchronously. And we'll add a first endpoint that will allow you to add the nodes. So that could be something like app.post, and the URL is nodes, and the response model is the node that got created. And we will define the behavior of this endpoint, and something like it should be asynchronous, as we plan to implement asynchronous endpoints. And we name it create post or note, and let's say the argument that comes in as a payload is node in. And we will build a query to insert nodes in the SQL Alchemy nodes table, and insert values. Values are that of the values that came as a part of payload. Node dot text, and complete status is taken from node dot complete. All right. Typo here. It should be completed. So once we have that in place, query built up in place, so we will execute this against the database and get the inserted record in a variable named last record ID, and we wait because this is a synchronous operation. Database dot execute the query that we have built, and finally we will return a note model. So which is in the response model we mentioned the kind of model that we are going to respond back to the user as a result of execution of inserting a new node. So it will have these three properties: ID, text, and completed. So here you see the node as a dictionary object that has been sent as a payload, and ID we are building it all afresh from the last record ID that got inserted. So that's how you implement a uh, insertion of new node, and let's go on with the execution of curl command and see how it will get inserted. So before we perform CRUD operations on our database, first create the database. So I'm on the PG admin screen accessing the instance of the database server, and here I the option to create a new database, and I'll name it FastAPI and click on save. Let me execute it one more time. Okay, it's already exists. And let me refresh the database server, and I should see the new fast API that has got created. So as of now, there are no tables because this is a fresh database that we just created now. And once we run our fast API, we should see that table that will be generated as a part of uh, the query that we wrote to create the metadata. So the line which is written here, metadata.create all of Indian, will take care of creating the schema that all does not exist. So let us see how that happens by running our application. So the command to run our fast API is Uvicorn main. Main is the name of the file, and app. App is the instance where the fast API is being initialized. And if you are initializing it in a variable app1, then it should be app1 here. So but we have app here, so that's what it is. And reload. So reload is actually to tell Ubiquon server to detect any changes while the Ubiquon server is running and reload the application completely with those changes in place. So let's run this and see by navigating back to the PG admin to have our new nodes collection or the table that is created with these three properties or not. So I'll go on ahead and hit on enter and wait for the application to start. Okay, the application startup completed. Now if I navigate back to PG admin, and when I refresh the tables node, I should be able to see the nodes collection with all the columns that were defined. All right, so let's switch back to our code, and So we were to insert a new to-do item in our notes collection, right? So for that, let me open a new terminal and type in the curl command to insert notes. All right, so the call command is something like this. I'm sending a post HTTP verb to this endpoint because this is where our endpoint lies on default port that we have been running our application on. Here you see the default port is 8000 that it has been running, and the headers are accept JSON, application slash JSON, and the content type is also application JSON. So these are optional headers, but here is the payload. So that follows hyphen D, wherein it is expecting a type of model which is not input uh, with a value, string value of text, and the boolean value of completed. So here you see the respective payload in the form of JSON, which is text, get groceries from the store, and the status of completion, which is not yet done. So let me execute this by hitting enter, and I get a response, which is actually the ID that got generated as a result of inserting the new node that I have sent via payload and the complete response of the node collection node entity. So let's switch back to our database and see. Uh, let's run a command by create a script, select script, and look it in our database. Select star from nodes and execute. And here we see. Okay, let's switch back to various code and uh, let's go on with the implementation of other endpoints. So the next endpoint we will implement is to retrieve a node given its ID. So for that, all you have to do is uh, to retrieve the node by using get method of app instance FastAPI, and the response model is uh, a list of nodes, or alternatively you can have a single node. Okay, so this endpoint, what it does is it will retrieve a list of nodes, paginated list of nodes, and every page has a collection of 20 nodes in each page. So that's the page size. So we will also implement an endpoint to update by having a put method on nodes, and it should return, and it should accept the node ID that's being updated, and in the response model we will return back the updated node. So the definition of update nodes will be something like this: update node that will take the node ID that's coming as a part of the URL, and it is a type of integer. That's what we are expecting it to be passed. If you have a node ID in the form of GUID, you can send G GUID. You can have it a custom GUID here as a type, and the payload is of type object note in, which is a model we defined using Pydantic library. And so we will build a query based on the payload. So and nodes update where nodes dot column dot id is same as the sent node id, and the values that we are going to set are passed as text read from the payload text, and the status of completion read from payload dot completed. All right, so now we will execute this query against our database because this is an asynchronous endpoint. Again, we have to await for the database to execute our query, and finally we will return the updated node and along with the ID of the node that you are requesting to update. All right, so we will again implement another endpoint to get a node given its ID. So all that we can do is by having app.get on the route nodes and the ID of the node that you want to retrieve as the part of the URL, and the response model is again the node that you are looking for. Be sure to have the specific type, because Python is case sensitive. And the next thing is we define the asynchronous definition for get node by ID, and it will take in the argument node ID, and it is of type int. So remember the pattern here, this and this are same, just because to parse the value that is coming in as a request as a part of the URL to be read in the Python as a variable. And we build the query again here uh, on the top of nodes collection, and then we looking for a node where the column ID is same as the sent ID. We then await for the database to execute our query, or we can alternatively say we are looking for one such node that has the ID that is sent, and we will return the node that is the result of the execution of database query. All right, so what left? So we will finally finish this CRUD by adding the delete operation. So delete is a HTTP verb that we invoke on the top of FastAPI's app instance, and that will expect you to send in an ID of the node that you want to delete, and so the asynchronous The definition to delete nodes is accepting a node ID that needs to be deleted, and we will build a query as usual to delete the node where the nodes dot column dot id is same as the one that has been sent in the request, and we will wait for the database to execute the query, and finally we'll return a message of type dictionary that has a key message and the node that got deleted. Deleted successfully. Yeah. So it's up to the decision of the team how they want to deal with the deletes. If at all there is no such node exists with the given ID, uh, even before deletion, then they may choose to send a 404. But if you see in real world, the deletes are idempotent, and you don't have a problem sending a different custom status code, then you can just send on a 200 all the time. Okay, so that's all about this implementation of CRUD endpoints, and we will go on to see by playing around sending certain curl commands that will actually perform the CRUD operations. Alright, so the first command that we are going to send again is the post command. As you can see, meanwhile, we have been making those implementations of different endpoints, and we have left our Uvicorn server to run in the background. You can see different reloads on every save of main.py file. So for example, if I just hit enter and save, you should see something that reloads the server. Okay, so here you see detected a change in main.py file and it is reloading. So that's the purpose of the reload argument that is being sent when spinning up the Uvicorn. Okay, so let's switch back to a different command prompt and send a new post request to our nodes endpoint. And we have two records now, and let's add one more nodes. Okay, here we go, and hit enter. Yeah, so now we have three records. We will send a get command to our API by typing in 8000 and nodes. So remember, the request headers are optional as I mentioned, and you should see all the collection of three nodes that were present in the database. So create of nodes is done, retrieval of nodes collection is done. Now let's retrieve a node given its ID. Suppose I want to get a node by ID 2. I'll send the command like this. Okay, so you see null because it is expecting a trailing slash. Okay, let's see what the problem is. Here is the problem. We somehow didn't implement the complete get nodes given its ID. So we'll implement. that. So database dot execute query, and we will return the query that will be executed. And hopefully the Uvicorn server might have restarted in the background. And let's do the get one more time. So if I switch back to the console, it is saying the response is not of a valid dictionary type. So changing it back to only one record, because the response model is expecting a dictionary of type node. So fetch one should do. Once we switch back to our query window and perform the curl request, no, it's not again. So what's the problem in here? Okay, so here is how it works. So you send the request like this, and you see the response, because there is no trailing slash that is defined in the method definition of the route. So if you end up adding a slash like this to each and every endpoint, it expects you to uh, re- have the request to be built in the same way with the trailing slash. Otherwise, you won't see the method not allowed. So that's the one important point to take care of. And okay, so one final time we query it for the node that has id 3, and you will see the text get some life, and completed is false. So now uh, we are done with the creation, retrieval of collection as well as given its id. Now we will send the curl command to update an existing node and see how that works. So we will go on by updating the uh, nodes collection that is having the id 2, and as you can see, the status of get some milk is not yet completed. So we'll, as we have brought some milk, let's assume, and we will update it to completed to true by sending the query as here. You see the completed status is being set to true, and you see the second node got done. And finally we go on with deleting a node, and the call command for that will be something like curl, and headers are optional again, and you can just give the id that you want to delete, and you will see the okay, here again it's not in having a trailing slash. So let's add it and send the request again to delete. So you see the node with id2 got deleted successfully. Now if you retrieve all the nodes, you will see only the node with id 1 and 3. So that's all about implementing CRUD. So if you found this video helpful, please give it a like and share it with your friends and colleagues. And please do subscribe to our channel, Tube Links. Thanks.